Hello everyone. In this video, we'll be discussing about the topic binomial theorem. So first, what is a binomial expression? So from the very name, bi means two, right? So binomial expression involves two dissimilar terms. So the definition is an algebraic expression which contains two dissimilar terms. Now let's say x plus y. Now this has two dissimilar terms x and y, and it is an algebraic expression with plus symbol in between them. Next, let's say x minus x squared. Now this is also an algebraic expression with x and x square as the terms. So basically these are the examples of binomial expression. Now in this topic we'll mainly focus on finding the nth power, or rather the expansion of the nth power of a binomial expression. So let's take a simple example, a plus b the whole square. Now a plus b whole square can be found out by multiplying a plus b twice, right? So and we get a square plus 2ab plus b squared. Similarly, a plus b the whole cube can be found out by multiplying a plus b thrice, and hence we get a cube plus 3a squared b plus 3ab squared plus b cube. Now these are pretty simple because we have to multiply them twice or thrice. Now how about a plus b the whole power n? Let's say a plus b the whole power 10. How will we find this? It's quite a tedious task to multiply it 10 times. So that's when binomial expansion comes into picture. So a plus b the whole power n is being defined as nc0 into a power n b power 0 plus nc1 into a power n minus 1 into b power 1 plus nc2 into a power n minus 2 into b2 plus and so on till ncn a power 0 b power n. So now in this NCR is nothing but n factorial by n minus r factorial into r factorial. I hope you are familiar with this term NCR, right? So other than that, we have got a and b, which are the terms which are included between them, and n is going to be the power. Now if we substitute the value of a to be 1 and b to be x, we get nc0 plus nc1 into 1 power n minus 1 into x power 1, that is nc1 into x, nc2 into 1 power n minus 2 into x squared, that is nothing but nc2 into x squared, and so on till ncn into x power n. So now that we know the expansion, let's observe certain things. The first observation which comes into our mind is the number of terms is going to be n plus 1. Now as you can see, it starts from nc0 and goes on till ncn. So which means it starts from 0 to n. So there are going to be n plus 1 terms, right? So the total number of terms in an expansion is going to be the power plus 1 numbers, right? So in this a plus b the whole power n, so it is going to be n plus 1 terms. So next property is sum of the indices of a and b in each term is going to be n. Now let's take this. The index of a is going to be n and index of b is going to be 0. So n plus 0 is going to be n. Similarly for nc1, it is going to be n minus 1 plus 1, which is going to be n minus 2 plus 2, it is going to be n, and 0 plus n going to be n. So this property is quite useful in checking whether you have written the term correctly or not. So if you have any doubt while writing it, just add these powers and check whether that is equal to the power of the power of a plus b the whole power n. The next thing which we are going to observe is the binomial coefficients of the term equidistance from the beginning and the end is going to be equal. So this is going to be the first term from the beginning, and this is going to be the first term from the end. So the binomial coefficients are going to be equal. So the binomial coefficient of this first term is NC0 and the binomial coefficient of this is going to be NCN. So we know a property that NCR is going to be equal to NCN minus R. So now NCN is nothing but NCN minus N, right? Because the R value is going to be N. So that is going to be NC0. So now NCN is equal to NC0. Right, so NC0 and NCN is going to be equal. So this is what we observe. So similarly for NC1 and NCN minus 1, and it goes on for every other coefficients. The fourth thing which we come across is, now it is quite difficult to find NCR value each and every time. So for that we have got a shortcut. So it is basically a Pascal's triangle. So let's say, so first, what is a Pascal triangle? So it is a triangle something like this. So the first term and the last term in whatever series, whatever line it might be, is going to be 1, and each term is obtained by adding the above two numbers. So let's say this 3. So this is obtained by adding 1 and 2, right? Similarly, this 3 is obtained by adding this 2 and 1, right? And this 4 is obtained by adding this 3 and 1. This 6 is obtained by adding this 3 and 3, and this 4 is obtained by adding 1 and 3. So it is something like that, and this follows till 10. Now the first line corresponds to the power n equal to 0. So I'll basically demonstrate this with an example. So let's say we have to find x plus y the whole power 4. So this is going to be 4c0 into x power 4 plus 4c1 into x cube y power 1 plus 4c2 x square y square plus 4c3 x y cube plus 4c4 x power 0 y power 1, right? So now for each coefficients we have to find this NCR, so that is quite tedious. So instead of that, what we can do is, the line corresponding to this power is going to be 4. So the line corresponding to this is going to be 1 4 6 1. So what we can do is, can directly substitute the coefficients to be 1 4 6 4 and 1. So this is going to be 1 x power 4 plus 4 x cube y plus 6 x squared y squared plus 4 x y cube plus 1 y. So this is how it works. So instead of finding the binomial coefficients separately each and every time, we can directly plug in the values from the Pascal's triangle. Right. So next we will move on to the general term of an expansion. So let's take, we have x plus y the whole power n, right? So the r plus first term is going to be equal to NCR into x power n minus r into y power r. So I'll just give an example for this. Let's say 1 plus x squared. We need to find the third term. I mean, let's take 1 plus x. So let's take 1 plus x cube. Let's say we have to find the third term, right? So third term is nothing but r. Now we have to find the third term. So r is going to be equal to 2, right? Because r plus 1 is going to be 3, so r is going to be 2. So now you can directly substitute the values. So n is going to be 3, so 3c2 into x power n minus r. So n is going to be 3 minus 2 into y power 2. So this is going to be 3c2 into x power 1 into y square which is nothing but 3xy squared. So this is how it works. So I'd like you to know that this is r plus first term, not the rth term. So r plus first term is going to be ncr into x power n minus r into y power r. Next we'll see what is the middle term of an expansion. Now this depends on whether n is even or odd. Now let's say if n is even, right? So if n is even, then there is definitely going to be an odd number of terms, because we know that there will be n plus 1 terms, right? So there is definitely going to be odd number of terms. So for odd number of terms, there will be only one middle term, right? So that middle term is nothing but the n plus 2 by 2 the term, right? Similarly, when n is odd, right, there will be n plus 1 terms totally. So definitely there will be even number of terms. Since it is even number of terms, there has to be two middle numbers, right? And those two numbers are going to be n plus 1 by 2 the term and the n plus 1 by 2 plus 1 the term, right?